Hey everyone, welcome back to the lab. In this video, we're going to be talking about my experience migrating from SvelteKit to F#. So for the past several months, I've been researching and experimenting with server-side rendering paradigms in F#. The recent server-side rendering trend, enhanced with things like Alpine and HTMX, has been interesting to me as it feels like a step forward for the already amazing monolithic architecture. This time, allowing you to reasonably move from two monoliths down to one for most applications. Yeah, and a lot of people don't agree with me on this, but I really think monoliths are an excellent architecture for most applications. I've got a whole post here on why I think that, and typically what I'm talking about here is what I see is really easy and scalable for most cases is if you need a different technology for your front end than you do your back end, like there's, the C#, F#, Java, Go, like good, solid back end languages. And then front end is kind of owned right now by JavaScript. And so if you need to do that, a great pattern is two monoliths, one for web, one for your back end. And that's kind of like how I've done things for the past several years. But with this new trend towards, server-side rendering, it feels like we might actually be able to do both in one, thus a single monolith. So some recent adventures in server-side rendering with F# that I've done recently is first looking into HTML templating with F#. Also looked at raw string HTML rendering because I didn't like the templates that much, and then eventually kind of wandered my way over into HTML DSLs like giraffe.viewEngine, and then did a bunch of benchmarks along the way. So in the last few weeks, I decided that I actually really liked this new approach, and my experiments at least proved that this wasn't an absolutely terrible idea, though, of course, time will tell. So I migrated my site, this one, over to server-side rendering on an F# Giraffe server. So yeah, if you come to HAMY.xyz, now running on F# Giraffe. So in this post, we'll explore some of the results from moving from my old stack, which was SvelteKit, over to my new stack, which we're currently running on F# and Giraffe. And so the main question we're trying to answer is what were the results of moving SvelteKit to F# and Giraffe, and any kind of metrics I was able to pull. All right, and so here's the high-level summary. My F# site is shiny and new and way over-engineered, and thus shows significant performance improvements of around 3x in both dev and prod, with payloads around 75% smaller than the same pages rendered in SvelteKit. In terms of developer experience, I think F# has an edge, if mostly due to its smaller number of components and packages to wrangle and stricter type safety, leading to less worry that I missed an edge case somewhere. And I will say that for type safety, TypeScript is actually quite good. I think it's a very good language, but the problem is that the whole JS ecosystem isn't fully TypeScript, and so in my experience, there's way more cases where you're using TypeScript, so your core blob of logic is pretty type safe, but you have to plug into all these non-type safe things on the edges, and there's just a lot of problems that kind of leak in that way. F# just has less of that because it's mostly fully typed, though we still have to deal with C# a little bit, which, doesn't quite have as good of a type system. So in the rest of this post, we're going to compare my new F# site with my old SvelteKit site from several different dimensions. So we're going to look at code, we're going to look at page performance, and then we're going to look at metrics from my sites actually running in production. All right, so let's start with code. So overall, the code base size as measured in lines of code from SvelteKit to F# remained roughly similar. That said, the composition of these lines changed significantly, with F# boasting fewer files and comments. Now, does this matter? Are comments actually a proxy of complexity? Maybe. Perhaps also a lack of expressiveness. I don't think even lines of code is that useful, but sometimes it is interesting to think about this. There's that one case study where they moved from C# to F# and the code got smaller, but crucially, they could check how many less null checks you needed because you're actually going to a type system that can express the idea of nothing without, the billion-dollar problem of nulls. And so I don't think comments or empty lines or anything really means much, but sometimes I like to wonder, if you can express yourself well in the code, do you need comments? And so there's going to be cases where, yes, you might need comments to explain why you do something, but I might imagine there would be less comments than if the code couldn't quite do something, and so you have to explain why it looks weird or something like that. Now, I'm not surprised by this result, as I actually admire both technologies for being simple and straightforward compared to their peers, which in my experience leads to less code bloat overall. And so therefore, I don't think either of these projects were very bloated, and so moving from one to the other, there's not much unnecessary fat to cull. This is one of the big reasons it's been my front-end framework of choice, it being SvelteKit, for the past few years. If I was switching from, say, a React app, I'd expect a lot more savings in terms of LOC. Okay, that might not be fair to React, but I am a bit of a React hater. And yeah, I think a lot of these like front-end frameworks so far, like I've tried Vue, I've tried Angular, I've tried React, and I just like don't love them. Like I think I've always just done them because it felt like the only way to do front ends that didn't feel like, dinosaurs and ancient. And I eventually fell into SvelteKit because, and I explain more here, in the HAMY burger, which is like my overall tech stack that I like to use for things. And I found that SvelteKit was like the most simple, and it was the most close to like the actual HTML I want to write, and I just have to have a little JavaScript to like get it to populate the data I want, as opposed to all these abstractions on abstractions to like render a dumb page like this one. So I think a lot of people will disagree with me. A lot of people love React. Just know that I'm a bit of a React hater. And I kind of explain why I think Svelte is better than React here, if you're interested in more of a dive in that. All right, and so I have a few hypotheses on like kind of why the composition changes. I didn't really think too hard on these, so they just might be totally wrong. But basically for SvelteKit, it's going to have a lot of just configuration files from JavaScript, just by nature of the way that like the JavaScript ecosystem is right now, where it's very fragmented and you've just got tools on tools on tools to kind of make up for the shortcomings of JavaScript itself, versus like what people are actually trying to use it for. And so there's just all these configuration files everywhere that you have to deal with, which I think just leads to more code, and then potentially also just more files, because there's just more things that are in your code base that is not the core thing. SvelteKit is interesting because it does its routing via the file system. So I don't know if you've seen this. I think Next.js is now similar, and there's like a few other frameworks that are similar, but it's basically like based on the route in your routes folder, that's the route that will hit that. And so you can have like server-side components and client-side components. But because of this, you don't need to like register routes as you would in like a different framework. So like have your list of routes and tell it like which handler it needs to go to and stuff. So this is going to lead to, in my opinion, less code, but probably more files, because you're often going to have like one file per route, whereas like another framework, you could have like all of them in the same kind of file. Same with like layouts, which is kind of like your styling kind of thing. This is also done via routing. So again, less code, but there's going to be more files involved. And this is kind of the same thing, just from the F# standpoint. Okay, so that's my hypotheses on why this is here, but let's actually look at the composition breakdowns. So here on the left, I've just got my SvelteKit. This is like from GitHub. If you look at your repo, there's usually on the like right side, it tries to figure out what kind of files you have in here and what's the makeup of them. And so here we see, mostly Svelte and then some TypeScript. And so I'd say this is like the core of the app. And then we got that weird like JavaScript stuff that we need. And then Dockerfile, which is how we run it. And then just some random stuff. And then for F#, we're like almost all F#. There's a little bit of CSS for actually styling it. And then we do have a little bit of JavaScript in here. And then Dockerfile. You might be asking, why do I even have any JavaScript in F#? Well, I think it's a little bit of JavaScript's okay, but this is actually over indexing because I'm using Tailwind currently to style my pages. And so I actually have inside of my F# a whole node project that's only job is to basically build Tailwind and then output it to .NET. And so this JavaScript actually doesn't exist in my file. I basically have zero JavaScript. This is only for the builds for Tailwind. And I don't have a post on how I do that yet, but I should probably get one soon. Okay, and now we can look at lines of code. And this is from Clock, I think, is what it's called. It's this command line utility that's like counts line of code is what it stands for. And so I just ran these on SvelteKit and F#. And crucially, I did remove all my markdown files because if all my posts were in here, like this would, you wouldn't be able to see the code. So this is only the code that is like included with the site, or that like is actually running it, if you will. And so for SvelteKit, we see like, again here, lots of Svelte, lots of TypeScript. And this is like the majority of the files here. And then we just have this like random JSONs and JavaScript and stuff here. And then we can see that, F# is right here with 1,800 lines versus 1,940. And this is where we're getting the 20 files from. And we only really have 9 files with logic in it. And these are the F# files. And that's where basically all the code is. All right, on to page performance. In this section, we'll compare my SvelteKit and F# sites in terms of page performance. SvelteKit is often lauded as a fast JavaScript framework, and it is quite fast. But JavaScript fast and F# fast are often two different beasts, even with your plethora of newly minted Rust-backed prototypes. They will likely one day catch up, but that day is not this day. And here's a link to my F# vs TypeScript performance benchmarks because, I ran some naive benchmarks across several pages I felt were representative of the kinds of pages on my site. Both to sanity check that my new site wouldn't keel over as soon as I launched it, and to check if the migration work had the perf upsides I'd predicted. In my naive benchmarks, my F# site loaded far faster than my SvelteKit site, even though they were presenting essentially the same site. It looks the same to me with the same styles and page content. And hopefully that's true. Hopefully if you used my site before and then you checked it out now, you wouldn't even notice it was a new site, except for maybe it's a little faster. F# seems to be rendering its pages faster and sending down much smaller payloads and much fewer requests than SvelteKit. And so the overall summary is that basically the page load speed, F# is rendering 2 to 5 times faster than SvelteKit for basically the same page. And then for page load size, F# is often 75% smaller than SvelteKit, although SvelteKit, interestingly, does sometimes have smaller payloads when it's a cached request. And this is something I probably need to look at for F#, although, probably doesn't matter that much. Now, before we go into any of these benchmark results, I always like to start off with the caveat that all benchmarks have asterisks. So I don't want you to take this as the source of truth or think that it's totally true. It's just so many things that are involved in benchmarks, so it just might not apply to you. These are just my anecdotal small n results. Okay, so what is the benchmark setup? Basically what I'm going to be doing is loading various pages on my site locally in an incognito browser. This is to limit any kind of other weird things that could be happening, like if I was hitting, a cloud service, is the container on? Is the cloud service having problems? Am I getting rerouted through a different, network? So to get rid of all that, we're just running it directly on my computer. And then I'm running an incognito browser because, all these extensions that you might have loaded, oftentimes they're loading themselves in the page, and we don't want that to be measured because it's not part of the site. Okay, and I've got two kinds of benchmarks I'm doing. So one is no cache, where if you Control-Shift-R, this is going to force reload of all your assets. And so this is a good way to see what would it feel like on a first page load because nothing is cached by my browser. And then the cache would just be a normal Control-R. So I'm just doing a light reload, which will reload the page. But if there's cached elements, it's going to try to use those cached elements as opposed to refetching them from the server. And also crucially for no cache, I'm vendoring all of my dependencies, at least for during this benchmark, through my website. And so we don't have any extraneous things from, fetching from CDN or anything like that. All right, how are we measuring this? So basically I'm just using Chrome DevTools for understanding the page load speed and then also checking the payload transferred. And that's how I'm going to be measuring how much was actually moved. I'm not looking at total because I don't think that really matters. If the total is really large, but you were able to, compress this so much that I only have a little bit over network, then I think that's what matters. And then the last thing to tell you is, the n is less than or equal to 5 for all of these benchmarks. For the most part, I only did a single measurement, but if it looked weird or something, I took a few remeasurements to make sure that this wasn't just a fluke, and then just kind of took the median of that. So the reason I'm putting this in here is, again, all benchmarks have asterisks, and one of the big ones here is that this is a small n study, so we can't really take any statistically significant results from this. All right, so benchmarking, the first page is my projects page, which you can see here. And basically it's just all my projects, and then it just puts them all in a big old list here. All right, and so for F#, we see it's loading in 77 milliseconds, which is 2.4 times faster than SvelteKit. And then for the page size, we're seeing it's 100 kilobytes, which is 75% smaller than SvelteKit for no cache. And we can see here that SvelteKit's at about 400 kilobytes and 188. And then for F#, 33 milliseconds for the cache. So we reloaded, but a lot of things are going to be cached by the browser, the CSS blob, any kind of JavaScript you have that's not cache broken, stuff like that. So this is 5.7 times faster than SvelteKit. And then we actually see here that the page size is 35 kilobytes, which is actually 15 times larger than SvelteKit here, which only has 2.3 kilobytes. which I think is pretty interesting. So my projects page is essentially a large HTML table. I was curious to test this one because it's one of the few pages on my site which consists of a large blob of handwritten HTML, as opposed to mostly dynamic content in the form of my blog posts, etc. For F#, the size of this HTML table is around 35 kilobytes. Other assets, mostly CSS, make up the other 65 kilobytes. And because these are the same, I would expect, the actual size of this table blob from SvelteKit to be the exact same. And so that's why I put this here. So should expect the size of all the HTML to be around 35 kilobytes. Now, I don't know why SvelteKit is sending 400 kilobytes for this. That seems like a lot, but I am impressed that on reloads, it was able to limit to only 2 kilobytes. This means it must be using some good caching mechanisms to make up for the initial load time, which I guess is what SPAs are supposed to be good at. The long load speed is puzzling, but I think this has something to do with the large number of requests SvelteKit emits to get its chunks, which takes a long time to resolve, even though the actual transferred payload is quite small. And so yeah, so basically this is just raw one big blob of HTML, and this was 35 kilobytes even with all the other assets cached. So we have to assume that the size of this HTML table is around 35 kilobytes with everything filled in, but SvelteKit was able to limit it to only 2 kilobytes being transferred. And my guess is what's happening is SvelteKit and all these other ones, basically what they're trying to do is they're trying to cache parts of the page, and they do this by chunking. And so I think that's how only 2 kilobytes needs to be transferred, because basically SvelteKit was able to figure out, hey, all my chunks are the same. I don't need to re-render. But I think it's interesting here because this actually took quite a bit longer to do, even though it's just HTML. And I think it's because actually the time taken to request all of these chunks outweighs the fact that you only need to fetch 2 kilobytes, because for every chunk, you can imagine there's probably some IO overhead. So this is my guess for why this is quite a bit slower, even though it's, rendering quite a bit or moving quite a bit less payload here. But I don't know. The one thing this makes me think about is that there might be some opportunity for me to be more aggressive for caching some of my pages client side in the F# app, since they don't change very often. And so this is kind of a move from SPA where you didn't really worry about this. You just kind of knew your thing was going to load slow, and then it'd probably be fast enough afterwards. But as we're moving back server side, we have an opportunity to play more with cache headers or request headers for caching. But if you do this wrong, you're going to break your app. So I'm still figuring this out because I haven't really done this stuff in a while. All right, the next page we're going to look at is my list page. And so this is, you come in here and you look at the lists, and then you're able to paginate and stuff like that. This is the list page. Okay, so for F#, for no cache, the loading speed is about 55 milliseconds, which is 6.5 times faster than SvelteKit. And then for page size and download, we do 79 kilobytes, which is 80% smaller than SvelteKit. And then for the cached page, so we've already cached the assets like the CSS probably, we're rendering in about 49 milliseconds, and then it's 7.7x faster than SvelteKit here. And here the page size, download size is only about 15 kilobytes. And so notice that these are similar, and my guess is because this is doing more work, and so the work that it's doing outweighs, the savings on network here. And the work that's involved is we actually have to go and fetch all the metadata for all these posts. And I could probably, do this better by caching some of the metadata, but I didn't. And compare this to SvelteKit, which is in the 300 milliseconds, and things to be snappy is usually gonna be 200 milliseconds, and then as you get slower than that, it feels less snappy. Although, we're kind of used to a lot of those websites that load in a few seconds because they're just kind of bloated, so it doesn't really matter that much. My list page is how I dynamically list all my blog posts in an ordered paginated fashion. It's a good page to test because it powers navigation for my blog, labs, and tags features. In this case, again, SvelteKit is sending down a very large initial payload, but interestingly, it also sends down a large payload on cached loads. I didn't take a screenshot of this, but if people are interested, I'll go back and set it up so I can get a screenshot of all the requests. My hypothesis is that a lot of this is due to how I dynamically loaded my markdown posts. Read not well. My node has never been that good, and so you can imagine that my SvelteKit invite was worse with less time to fail and learn. It seems that the way I was generating my pages led to lots of empty requests from the client for all my blog posts. Blog posts that shouldn't show up on this page were still getting requested with empty payloads. Again, so it's kind of interesting, the way I had to do this was to dynamically load my markdown server side though, so it shouldn't be on the client. But it seems even though I was doing all this stuff server side, and then I was, doing the pagination server side, and then only finding the posts that were required and sending them down. It seems like a chunk is made or was made in SvelteKit for each one, even the ones I didn't send down. And so like I only want 10, and so those 10 with their like front matter or their metadata are sent for the pagination. But then I get like over 100 different requests for chunks that are empty, which seems to correspond with all the other files that I saw, which seems weird and pretty wasteful to me. Now, I don't know why this happened, and really should just be chalked up to me coding bad rather than SvelteKit being slow. But at the same time, I built my F# site with dynamic markdown loading fine without this issue, so take that as you will. And sometimes I feel like it's like that dynamic thing, or it's like, or the design thing where it's like, if you fail, okay, maybe it's your bad, but if like a lot of people are failing on the same thing, it's like actually just bad design. And so I think in this case, it probably was just me coding with SvelteKit wrong, and I didn't understand how to load files and stuff. But I'm kind of like, if other people are running into this too, it might just be bad, confusing design. And I don't know which one it is, but let me know if you've also run into this with the SvelteKit before. My next page is the tags page. And so, I can click into tags and I'll just like get all the posts that are related to whatever this thing is. And you can imagine that this could be kind of complicated because this is like a one-to-many that you kind of have to build at some point. And that's why I wanted to test this one. So real quick, for F# with no cache for about 74 milliseconds, which is 5 times faster than SvelteKit. For the page size, it's about 80 kilobytes, which is 80% smaller than SvelteKit. For the cached version, we're finishing in about 60 milliseconds, 7.5 times faster than SvelteKit. And then for the payload, it's only 15 kilobytes, which is 80% smaller than SvelteKit. So the tags page is a good page to test because it's arguably the most resource-intensive operation aside from markdown parsing. Here we have to get all the posts for a given tag and present them in sorted order with pagination. So you can imagine like different ways of doing this. Like if you're doing it on request, you might just like have your tag and parse through all the front matters of everything and get the posts back that like, actually match the tag. You could pre-compute this. You could, hopefully those are the only ones you're doing, right? Like, cause then that'd be like an O of N operation. So hopefully you don't want to get worse than that. And so on the SvelteKit side, I believe I am doing the linear version where I have my tag and I just look through all the metadata I have on all my posts and get that. But for my F# tag engine, it's much more optimized because basically what I'm doing is when I spin up my app, I'm looking at all my posts to kind of get an index of what is in there. And this includes things like, what slugs do I have available so I can return on miss very fast. Things like the tags. I'm basically getting all the tags and grouping them. And so this, costs more memory for me, but this means that on an actual request, I have an O of 1 lookup plus whatever the, parsing time is for these requests. And so because of this, because the F# version is definitely a more optimized algorithm, this makes sense to me why the load speed is so much faster. But I don't know about the page size because theoretically the page size should be the same. All I'm sending is that list of article names and like the little metadata. So it's odd to me that these are so much bigger, but maybe that's just a spa for you. All right, and now we're gonna go and look at a basic post. And that's basically what I'm on here is the basic post, but it just looks like this. And so for F# for no cache, the load speed is about 56 milliseconds, which is 5 times faster than SvelteKit's loading of the same exact post. And then for page size, we're at 71 kilobytes, which is about 80% smaller than SvelteKit. For the cache, it's 4.5 times faster than SvelteKit at 51 milliseconds. And then for the page size, it's 7 kilobytes, which interestingly, again, is 75% larger than SvelteKit. So finally, we get to a post page, which is important because my site is all about posts, sharing my words with others. If this page sucks, then the whole rest of the site is useless. I chose this post in particular because it doesn't have any external media, which would contaminate my benchmark with extraneous factors. So like this post, I've actually got a lot of media in here. And so this means that, all sorts of things like my network speed and the CDN's network speed and stuff like that would get in the way. Now this page is arguably the most resource intensive in terms of markdown parsing due to its need to load the full content as opposed to, just like the metadata section at the top. Now, as expected, F# runs much faster with a smaller initial payload, but again, we see that SvelteKit returns an impressively small payload on re-renders, which beats out even F#'s minimal. And so I'm feeling like there's probably a way to do this like server side or a way that's like easy to get this working without too much effort. I don't know what it is though. So let me know if you have done this server side where you're like chunking and it's actually useful, because I'd be interested to see what that looks like and kind of what's involved. All right, now on to production metrics. So the previous benchmarks were all run locally on my machine, in dev, you might say. But as we all know, dev is not equal to prod, and I believe you should act like it. So in this section, I wanted to record some prod metrics to get more of a feel for how these two sites perform in the real world. These metrics were pulled from the Google Cloud Cloud Run dashboard where I host my sites old and new. I've used Cloud Run serverless containers as my primary hosting method for the past several years and really liked it, which is why it's part of my 2023 core tech stack. Yep, really like serverless containers, think this is the future. Serverless functions, I don't think work very well. We've already seen it not really scale as we want, but serverless containers, on the other hand, gives you a ton of freedom to build as you want. It's super simple, and these things outperform functions as soon as you hit real load, basically. For an idea of scale, my sites get about 5,000 views a month, which comes out to about 166 views per day, or 0.002 requests per second. So like no load really. But hey, that's real life. Despite what your software engineering interviews might lead you to believe, most systems don't have much load either. Yeah, a few things here. I write reflections every year and do kind of like readouts kind of like this, but like for my life and for my projects and stuff. And so that's where this numbers comes from. I do a readout every year on this. For small load, like most systems don't actually do that much load, but the complexity comes in like organizational complexity of like the size of both the org and the amount of people you have to deal with, but also the many different use cases. And so if you're actually to look at like a single one use case, like running the website of your company or like your business or whatever, usually that load is going to be really small, but then it's only when you combine it with like the 100 or 1,000 other use cases you've got that it starts to get large. But this is why I think it's funny in like software engineering interviews, because they're usually only like one use case. And if you actually work backwards to the amount of load they're trying to handle for a given use case, it's either very large, and like unrealistic, or it is realistic and it's like super small. And it's like you could just run this on like a Flask server and it would be more than enough. All right, and so here's just some readouts on these. I'm not going to get too much into them, but for request latency, SvelteKit was doing about 30 milliseconds per request, and F# is doing 10 milliseconds, which is 3 times faster. For CPU utilization, we're at about 1% for both of these. You can see this line, at the very bottom of the chart. And yeah, you could say maybe like, SvelteKit spikes a little bit higher at max, but like, does it matter? Not really. And we can see that neither SvelteKit or F# are trying very hard because my sites just really don't get that much load. 0.002 of a request per second is like nothing. For memory utilization, we're seeing SvelteKit at around the 28% mark, and then F# is around the 35% mark. It makes sense that F#.NET use more memory because they're, little memory hogs. But typically this comes with the trade-off that they're faster. And so usually I'm not honestly worried about memory until we start seeing those spikes, which means that, we're being kind of constrained by the garbage collector. But I wouldn't really expect to see that here when we're not really using much memory for any of the operations. For startup latency, SvelteKit's at 3 seconds. And F# 7 seconds. So this is how long it takes to create a container. And I will say that this is one of the downsides of like container or serverless containers, is that they will usually take longer times to spin up than like a function. But I think it has very similar characteristics to like if you think of a function as like a dynamic language and a container as like a compiled language. They have very similar performance characteristics, and like what are the trade-offs of that fast startup time. Usually it's in long-term performance. And so we see that here too, where like, F#.NET is just slower to start up than SvelteKit and Node. And this is just a common trade-off between dynamic and compiled languages, where dynamic starts faster, but is just slower long-term, assuming you have a large enough time horizon. And so in the same way that like, your functions can start up immediately, but they're usually constrained in how much they can handle at one time and like all sorts of things like that. You can win out long-term if you have like a beefier thing like a function or like a compiled or a serverless container or compiled language, which works at scale. But like if you're not at a scale where, you have a time horizon and that's long enough and enough load to actually make use of the concurrency and speed, then it just might not matter to you. And that's the trade-off. F# definitely overkill here. but startup latency is really just not that big of a deal. People will wait on a website. And as we saw, my average request latency is still, way faster than SvelteKit. So even if this is much higher, it's kind of amortized across all the other requests. So overall, I'm very happy with my new F# site. It allows me to play more in a language I enjoy, and I think has some sizable DevX and performance advantages, even though it doesn't really matter that much. At least not in the grand scheme of things. I've enjoyed the full stack F# experience so much that I've also decided to migrate Cloudseed, my F# project boilerplate, over to this stack. I use Cloudseed as my base template for starting most of my projects, so it makes sense for it to migrate along with me. And so I've talked about this a lot in the past, but this used to be like SvelteKit on the front end, and then F# on the back end, and then Postgres is the database. And this is again that kind of like two monolith structure that I'm talking about. That's like the simple scalable system for, building most applications essentially. But because F# one has like good tooling for HTML, but also we're starting to see like some impressive tools in my eyes, like Alpine and HTMX, that are allowing you to get more of that reactiveness baked into your HTML. It means that we can now kind of combine this into one monolith, with that, which I think is like really cool. And honestly, probably this idea of full stack monoliths is going to become even bigger for more backend languages. We're already seeing it with Next.js, SvelteKit, Astro, things like that on the front end side, if you like JavaScript. But if you don't like JavaScript, which is like a lot of people, we're now starting to see that capability emerge here, which I think is very exciting. So if you like this post, you might also like this post here, where I go into how to build your own Markdown blog with F# and Giraffe. And this is basically the core of what I use for my site now. So check that out if you're interested in doing that. The HAMY burger, which goes into basically all the core technologies I would choose in my tech stacks, and then a few alternatives if you don't like those specific ones. And then finally, if you're just into benchmarks and, want to see how much better F# is than TypeScript, you can check out this benchmark, which kind of compares their performance characteristics. That's it for this video. Thanks for watching, and I'll see you in the next one.